unit vectors brings us to the next topic, which is scalar product of two vectors, also called dot product of two vectors. What exactly is dot product? In vectors, unlike in scalar algebra or unlike in arithmetic, there's only one type of multiplication arithmetic between two numbers, and you can multiply them in any order and in any way you can, and that gives another number. However, in vectors there are two types of multiplication. One is called vector multiplication and one is called scalar multiplication. So scalar multiplication is a comparatively simpler version of vector multiplication. So this involves two vectors, and when you take the scalar product of two given vectors, then you get basically the direction of one vector in another vector. That is, how much portion of one vector is going in the direction of the other vector is what is determined by the scalar product of two vectors. Let us see. Let A bar and B bar be two non-zero vectors inclined at an angle theta. Now it is possible to have any two vectors which are in the same plane, or at least two vectors which are on parallel planes. So even when vectors are on parallel planes and they do not necessarily intersect each other, they are still considered to be coplanar vectors. So if you have A bar and B bar as two vectors which are inclined at an angle theta, then the scalar product of A bar with B bar is denoted by that notation, A bar dot B bar, and is defined as the scalar quantity magnitude of A bar times magnitude of B bar times cos of the angle theta. And what is theta? Theta is the smallest angle between them, the acute angle, if possible, between them. So here's a schematic showing this. So OA represents the vector A bar, OB represents the vector B bar. So therefore A bar dot B bar is equal to magnitude of A bar times magnitude of B bar times cos of the angle between them. So that's what the dot product of two vectors A bar and B bar is equal to. A bar dot B bar is equal to magnitude of A bar times magnitude of B bar times cos theta. So therefore, another way of looking at this is by writing A bar dot B bar as magnitude of B bar times projection of the vector B bar on A bar, or in other words, how much portion of the vector B bar is going in the direction of A bar, and that is obtained by taking cos of the angle between B bar and A bar. So that gives us magnitude of A bar times projection of B bar on A bar. You can also flip this the other way around, and you could say that I'm trying to find out how much portion of the vector A bar is going in the direction of B bar. So both the statements are equivalent to each other. So therefore you can also write A bar dot B bar as magnitude of B bar times projection of A bar on B bar. How much portion of B bar is going in the direction of A bar, or how much portion of B bar is going in the direction of A bar. Projection of B bar on A bar. So this brings us to officially discuss the topic of projection of a vector on another vector. So what is that? It's basically the fraction or the percentage of a vector which is going in the direction of another given vector, right? Like for example, when a ball is shot up into the air, there is some component of the vector which is going in the horizontal direction, which takes it away from you, and there is some component in the vertical direction which is taking it above you. So therefore these two vectors combined to give the trajectory that the ball takes. So therefore projection of B bar on A bar is A bar dot B bar divided by magnitude of A bar. So you can write that as A bar divided by magnitude of A bar dot B bar, which is A cap dot B bar. You can also look upon it as A bar dot B bar divided by magnitude of V bar. So therefore that is A bar dot B cap. So projection of A bar on B bar is A bar dot B cap. And projection of B bar on A bar is A cap dot B bar.